Okay, so the purpose of this is going to be to make a pretty huge connection between a lot of the factors that you guys are studying in class and a lot of the things that we're hoping that you understand. At first look, this looks insane, I'm sure. This is a pretty intense diagram, and what this contains is really all the relationships you need to understand between the biomes, precipitation, temperature, sunlight, air pressure, all of those concepts are contained within this one little diagram. So we're going to start by pointing out just kind of how the diagram's laid out. This is your latitude down here. So anything along the middle section of the screen is really telling you what things are like at the equator. Now, as we move to the left or to the right, we're going to either move north or south from the equator. So moving and to the left is what we'll start with here. We're going to gradually start to move up towards the North Pole. Up at the very top, that would be the North Pole. And if we go to the right here, by the time we get to 90 degrees south, that's going to be our South Pole. So what does this mean? Well, really, what we're looking for here are the general relationships and some patterns within the biomes. And what I want you to notice first is we kind of go dark green, light green, brown, light green, dark green, light green, all white. Um, what this is showing you is that there is a lot of vegetation here and that you gradually end up having less vegetation until you have almost none. And then you have a little bit more until you have lots, and then a little bit less until you have none. And it works that way on both sides of our planet, both the northern and southern hemisphere here. So really the question is, why does this happen? So the first thing we're going to talk about is direct sunlight. What you need to know is that the middle portion of our planet is getting pummeled with direct sunlight. And you can see here anywhere near the equator, we've got direct sunlight hitting really hard. So that means that this area near the equator is receiving light that is shooting straight into the equator. And essentially the equator is catching the full force of our light from the sun. So this is going to be your hottest region for that as well. The equator is going to be our hottest region. Um, this has a profound effect on all the other variables. So the idea that this section gets hotter than any of the others, that's really, really important. This section, however, is going to be receiving the least amount of direct sunlight. In fact, we're going to say that it's indirect sunlight. To help you visualize this, go ahead and think of someone punching your face. If they punch you square in the center of the face, they're going to hit you pretty hard with all the force. However, if they just graze the top of your head, like the sun does with our poles, it's going to be just a glancing blow. It would be an indirect blow. So when we say indirect sunlight, that's what we mean here. So this section near the North Pole and this section near the South Pole receive indirect sunlight, and that's going to make them a lot colder than things would be at the equator, where they're essentially getting smashed with sunlight on a regular basis. So this explains some of our temperature patterns. All these sections in the middle here are going to be hotter than these sections on the far end of our planet. And again, that just has to do with direct sunlight towards the middle versus indirect sunlight on the edges. Now, this is also going to play a role in how wet regions of our planet are. So I need you to bear with me. This is definitely the most complicated part of this entire screencast here. Hot air is going to have fast-moving molecules that spread out and they become less dense relative to cold air. What this means is this is going to be less dense than this. And that's very important. What that tells us is that this hot air will rise. The same reason that a hot air balloon rises, or that, like, let's say you got a little toy ducky in your tub that floats, it's less dense, so it is going to move towards the top. So this rising air has a big effect on what water can do. When warm air is rising, that air is not going to be pressing down as hard as the air would be if it were cold and sinking. So this air that's hot and rising lets a lot of water vapor rise with it too. And what we end up with here, any place where air is rising, you're going to notice ends up being really wet. And the reason for that is I want you to just think logically. You've probably heard the saying, what goes up must come down. So something that is uh, if we have a lot of water rising up at a certain location where it's hot and the hot air is rising, then that water is going to have to fall back down. And it does that. It gets cold up in the atmosphere and falls back down towards the surface of the earth. And what you end up with is all this water here kind of really soaking the central portion of our planet. So you would expect to find really wet, warm biomes in this region. And that's why we have a lot of our tropical forests near the equator. Something weird happens though. In a perfect world, you would just have the hot stuff rising here and it would sink all the way at the poles. But in reality, our planet is so big that our air cannot make that full journey. It can't make a full circle. So what ends up happening is the hot air rises, but it gets cold in the atmosphere. And right at about 30 degrees north and south, that air is going to fall back down. It gets too cold and it sinks back down towards the surface. And it happens here too. So it rises up at the equator and then sinks back down at 30 degrees latitude. So what you're going to end up with is this cold sinking air. It's pushing down on our planet. Literally, it is applying high pressure is what they say in meteorology terms, but really what they're just saying is this air is pressing down on the planet. So if I'm a little puddle sitting here in this region and I'm trying to evaporate up into the atmosphere, I'm getting pushed down by air. It's difficult. It cannot evaporate easily. So when you have a low amount of water evaporating, you've got nothing going up, so you're going to have nothing coming down. You're not going to have much precipitation in this area. What you'll see is where it's rising, it's wet. Where it's falling, it's dry. So where the air is falling, it is dry in those regions. So you can see that connection here. And you're going to notice these middle areas. This is where you would tend to find most of your grassland biomes would be in the in-between areas, between where it's wet and dry. And the main reason for that is, they don't have enough water to grow large trees in any of these grassland areas. They have enough water to support grasses, which don't need as much water, hence the term grassland. So these in-between areas where the air is rising and sinking, you're really going to see most of your grassland type biomes or your biomes that have plants that can survive with a medium amount of water. Okay. Now for the weirdness. So we've got hopefully a decent understanding of why this air rises. It rises because it's hot. And why this air falls. It falls because it gets cold and falls. And we probably have a good understanding of why this is sinking because it's so cold at the poles. This is going to be our heaviest air. Of course it's going to sink. It's going to be the most dense air on the entire planet. The question is, why does this guy rise right here? And I want you to think logically. I want you to picture a fat guy up here, a real big human being, and another big human being right here, and pretend that this is one of those things you would see. They call them blobs out at like a lake where people jump into the lake, okay? And I want you to picture a little girl sitting right here at this location. If I have a big man here and a big man here, and they both jump down on one of those big air blobs, they're going to rocket this little girl flying way up into the air. This is the same concept of why we have rising air at 60 degrees north and 60 degrees south. It is the idea that air is pressing down here and air is pressing down here. So this air in the middle at 60 degrees has nowhere to go but up. It kind of gets forced up by these two locations. Because the air at 60 degrees north and south is being forced up, we would expect to see large amounts of evaporation. It's easy for water to get up there. When it's easy for water to rise up into the atmosphere, that same water is going to fall back down. So this is going to be this location here where it is wet. You're going to see a lot of your temperate forest That's kind of where we live in Ohio, would be right in this vicinity. We're on the lower end of that, actually. But and you would also expect to see the same patterns down here. The Taiga biome is kind of like a grassland, only the grasses that we would expect to thrive and survive in these regions don't do as well in the taiga because it doesn't receive as much direct sunlight. So there's a type of plant that's really specialized in this region. We call them conifers, or we call them evergreen trees. You might think of them as the standard Christmas tree, perhaps. But these are plants that have tiny needly leaves, and they thrive in this region because they can do well with medium amounts of water, and they do well when they don't receive a ton of sunlight. So they kind of outcompete those regions. In general, a quick summary, we're going to have our wettest and warmest climates here. We're going to have this variance in the amount of rainfall we get, and that's again due to the air pressure in these. It's going to be really wet where you have low air pressure and rising air, and it's going to gradually get drier and drier until you get to the point where you have the least amount. And this would be where you would find most of your deserts, right around 30 degrees north and south. We are also going to see it kind of flip a little bit, moving upwards. We're going to go from where it's really dry, and it's going to slowly start to get more and more moisture in this region. So we would have more grasslands until we get to our next forest. And these are seasonal forests. The only reason they're not like tropical forest is, you guys know this very well, we only get direct sunlight, a lot of direct sunlight in our summer months. So we're going to have more of a seasonal type forest here, a temperate deciduous forest, if you will. By the time we get up towards the poles on either end of this chart, you are going to hopefully know that it's going to be cold, duh. But you should also know that this is one of our driest regions on the entire planet. And you might think to yourself, well, why is there always snow there? Well, the reason is it never melts. That snow has been accumulating since it's been snowing on our planet. You know, there's snow there from a very long time. So if you were standing at the North Pole or at the South Pole, you shouldn't expect to experience a lot of precipitation. And that's because the air pressure there is so high, the water can hardly ever evaporate, and you're not going to end up with a lot of moisture in your air in those regions. This is the general rundown of our biomes. Now I want to show you in this, hopefully, I want to show you our patterns on the actual planet. So if we look here, this is where the equator is on the map. And you can see it's very green in this region. All right. All the land masses that run through the equator are bright green, and that's because it is wet, right? And this area is also where we have that rising air, so it lets a lot of moisture evaporate and get up into our atmosphere and rain back down. This is around 30 degrees north. And you can see, as a general rule, it's pretty dry here. There are some locations that are right next to the ocean that still manage to get enough water, this and this. But in general, it's very dry around 30 degrees north. You're also going to see that it's pretty dry down around 30 degrees south. Australia, the majority of Australia is very dry. Only the parts that are near the ocean are not. So that's 30 degrees and 30 degrees, a lot of desert regions. As we slowly move away from those desert regions, you'll see it gradually starts to get a little greener and a little greener. Your grasslands would be found in there. Then you get up into this vicinity and you start to see your temperate forest. You move upwards towards this region, and that's where all those evergreen trees are located in the taiga, the things that do well with just a little bit of sunlight and enough moisture. So lots of trees in this vicinity as well. The taiga region houses most of our trees on our entire planet, aside from the tropical rainforest. So good information to see there. I've had kids ask me, well, why don't you see a lot of green down at 60 degrees south? Okay, so here's 30, it's dry. Well, the answer to that is there's no land down here at 60 degrees south. There's very little land in this vicinity at all. So if there was, you would expect to see a taiga type biome. And then, of course, you get to the poles and you see a lot of stuff that's been frozen there for a long time. Don't let that fool you. It's a very dry location still. And you can see the same thing with the tundra type biomes here. So hopefully this helps you a little bit. Try to understand kind of some of the patterns that are on the globe. I encourage you to explore the map a little bit more and investigate some of the other things. We'll be talking about them later, like mountain ranges that can cause you to have some wet-dry patterns that you wouldn't otherwise have. But explore that, see if you can figure anything out just by looking at the maps. There's a lot your world can tell you just by making some observations. Hope this helps. Have a great day.